It's good to be here in Barcelona with OpenNebula. We're going to show you briefly what we are trying to do a fast implementation of OpenNebula with some other software to recreate a central office. If you're aware, the topology of a telco is very simple. We have central offices, which are the closest point to your access at home, at the office, or a mobile network, mobile access network. Then we have a ring of regional central offices or data centers. And at the center, we have strategic data centers. In Telefonica's case, we have 4 globally, 1 in Spain, 1 in Miami, Florida, 1 in Brazil, and 1 in Mexico. Okay, that's our footprint, more or less, to give you an idea where we are at. Regionals, it depends. You know, in Spain, we might have 8 regional data centers or central offices. And access central offices in Spain, we have right now about 2,500. But with fiber optics, we're able to reduce that number to about 800 to 1,000. So since we are having fiber optic access to all the houses and to all the premises of enterprises and to our mobile network, what we have decided is to say, well, if we're doing this, why don't we go one step further and taking into advantage cloud and software-defined networking and network functions virtualization? Why don't we collapse the central office, take all the equipment away, and put a cloud solution on it, on each central office? Why? Because today, if you go into a central office, this is what we have. We have hundreds of black boxes that have all kinds of services and all kinds of proprietary software and proprietary hardware. And we have hundreds of protocols as well, and systems, and not only protocols, but we have also operating systems in there to make sure that we provide the services, 3 basic services, which are voice, data, and video. And why do we have this situation? Because over the years, we have built service upon service. You know, Telco started with a voice service, and then we moved into data, and maybe 10 years ago, we decided to provide video or TV. So to do that, we put box upon box. So what's happening? That to maintain this is extremely expensive, and as you know, the competition and prices of your connectivity are lower and lower, so we cannot sustain this model. This model is not sustainable. So about 5 years ago, ON.Lab, which is an organization from Stanford and Berkeley University, together with Google and Verizon, decided that maybe we could separate the control plane from the data plane. And that way we could make everything programmable and take away the intelligence that was built on these boxes, strip it from the hardware, take the firmware away, and control with commodity servers. So you pass whatever control was built in here, you pass it on to software and put it on top. And also we decided at the same time that we don't need as many protocols. We don't need ATM, we don't need GMPLS, MPLS, so we decided that why don't we use IPv6 as the basic connectivity protocol, the HCP, tunneling, Ethernet, of course, and SDN. What happened here when we decided to use software-defined networking? We were able to strip all the major operating service systems, which is a huge investment that we have in software there. So basically, then we decided, let's move everything to x86. As we build this, we can have this tailor-made for us as well. We don't need to buy it today this thing is like a huge box that we buy from 2 or 3 vendors. We said, no, well, we can have it manufactured for us. So we took advantage of 3 things. As I said, OpenFlow. Then we joined the Open Compute project, which is what Facebook did to commoditize servers and switches. And together with AT&T specified the OLT. This is where your optical cables come through from your house, and they connect here. So we decided to do everything programmable. And it was very simple. Why do we do this? Because we find out now that let's go to English. Sorry, it's just bilingual. So here. Why did we decide to do this? Right now, you heard about edge computing. It's in vogue today. We must have mobile edge computing, fixed edge computing. But really, Telefonica or any telco is the closest point between a user and edge computing. And there is no other point of connectivity closer. So we own that property. We own all the central offices. So you're here, and here's your first port of connection. So we decided that, okay, well, fine, if we are capable of transforming our central offices into data centers, we have 800 points of presence in Spain, more than 800, while any competitor of us will have tens, maybe 100. So if we put commodity hardware with OpenNebula, with any cloud solution, then we're able to provide somebody a capability of being very close to the end users when they want to do gaming or watching TV or do some virtual reality, which is a problem right now to really have virtual reality if you have your data center hundreds of kilometers away. We're only 20 kilometers, the furthest distance between an end user and our services will be 20 kilometers at most. And fiber optic time, that's almost negligible. So, but if you have your data center in Ireland or whatever, and you're providing services in Spain, the physical distance impacts the virtual reality. So it was an advantage that we had. And then we decided to do this. We said, okay, fine. If each central office is connected to the fiber, and we remove everything away and put this equipment and this solution, which David will explain in a few minutes, then we're capable of providing the basic service, which today is all IP. Voice is over IP. The data, the video comes over the IP network as well, and of course data. So this is what we decided to do, and we had been planning this for a couple of years, and then David, which leads the project now, came along and he said, well, let's build it. So he's gonna explain to you how we build this thing.
You hear me now? Yeah. Okay, so my name is David, as Alfonso said. Good morning, everybody. Yeah, so this was a nice vision. So we said, okay, how can we build a central office using software on top of this infrastructure? There was a reference implementation coming from ON.Lab, which is called CORD, is the central office architected as data center. So we get inspired by this reference implementation, but we did some adjustments or changes to fit it to our needs. Okay. So the first thing we need was a Vim. Okay. Some software to manage the infrastructure and virtualize it. Okay. So we turned to OpenNebula. Why? Because it's a very nice project. As you all have seen during these days. It's flexible, it has APIs, easy to use, very lightweight, and quite convenient for us to do a very fast prototyping. When we decided to build this, it was around May. And we had like 3 months to build the first prototype. It was quite challenging in terms of time frame, but we wanted to use tools that are simple to use and enable us to go really fast. Then for the SDN controller, we choose ONOS. ONOS is the SDN controller that comes out of the core project. It's open source as well. And implements the OpenFlow stack. Implements the implements the OpenFlow stack plus other modules, and it's extendable. Okay, you can create applications inside of ONOS. Some of them were available because of this core project, but there is a Apache Karaf framework to develop the Java modules for ONOS as well. And you see that we have some computing resources here and some switching close fabric. We didn't have time to get the switches, so we built the switching fabric with software as well. We use the Mininet project, which is a very nice tool to create networks, and we build exactly the same switch fabric that you saw in the picture using this software. And for the OLT is the equipment that connects the fiber coming from the users. From the OLT, we use Mininet as well, because at the end of the day, the OLT is seen like a switch, level 2 switch for the SDN controller. And then inside ONOS, we use several applications that were available from the core project. We made some changes to some of them to adjust it to our needs because we were using IPv6 all the way. So we have the application that controls the OLT. We have the close forward application to manage how the IP packets are being forwarded inside the switching clause. We had the virtual router to get the traffic out of the central office to the transport network. And this one we didn't use because it's to manage the connectivity to the optic network in the central office. But we didn't use this in this phase. And inside OpenNebula, we created a number of virtual machines. One of them is the CDN. We use a solution coming from Akamai for the CDN. And the idea is that in the central office, very close to the users, we can create a CDN hypercache that we can distribute content from there, okay? We integrated some live TV content from our TV platform, Movistar Plus, yeah? So when a user was selecting some TV channels in the Zombie applications, we were fetching the content right from the central office. And this has a lot of benefits for the operators because we can reduce significantly the traffic in the transport network to carry all the video content for all the channels to deliver the TV content to our users. And then this virtual PDC, this stands for cliente, is the virtual router, the virtual CPE that we instantiate for each user in the central office. This is more or less the setup that we did, okay? So we had a fiber connection. We use an Ethernet level 2 connectivity here that connects the devices from a user's house. It's connected to a bridge in one of the hosts that connects to the OLT. This simulates the fiber getting to the central office, okay? The OLT is connected to a captive portal, so we set up some rules here so that all the traffic is going to the captive portal when the user connects the first device. We split getting connected from the central office to get an internet connection service. Okay, so the user first need to connect to the central office, and then he goes to a captive portal that lets the user select what is the speed for the internet access they want to use. Okay, once the user select this package, this connectivity package, we change the rules in the OLT to send the traffic through the router that we create for this user. All the traffic goes through the switching clause and goes to the internet through through this router here. Okay? And then we add a couple of services, third-party services. One was the CDN service, and the other one was a parental control service based on DNS resolution, because all the DNS resolution is happening inside the central office. We can filter what content is accessible to our users and which content is not. So this is the view. We have users that are connected to fiber, goes to a virtual CPE, a virtual router in the central office. From there, they go to the internet, but we can deploy additional services in the central office, we're especially interested in third-party services here, so that we can enrich the service catalog that we can provide to our users. And for us, doing an upgrade of a service for a user or adding additional services to users is just a matter of changing the connectivity with the SDN controller for this virtual machine, which is quite simple, and you can do it in real time. You don't need to wait for days for this to happen. This was the resources that we use. We use a couple of servers, just a couple of servers. We create a number of virtual machines with different settings. We had the OpenNebula software running in one virtual machine, the captive portal, the ONOS SDN controller, the mininet for emulating the OLT, mininet for emulating the switching clause, the DNS parental control service, the CDN, the router to get the traffic out of the central office. This was a virtual machine to emulate a client inside the central office. This Iris machine is something that we did pretty fast as well, because all the elements are running in virtual machines, as you see. We install some agents in each virtual machine to collect the logs. Okay, so we are fetching logs for all the virtual machines and sending them to Elasticsearch deployed here. And with Kibana, we can build dashboards that instrument all what is happening in the central office. So we have views on what resources are consumed, how they are consumed, what processes are consuming more resources. And we can do cool things like logging what are the DNS resolutions that are happening in the central office and classify them. So we can detect, for instance, what is the most interesting content for the users connected to the central office. And this virtual PDC is the virtual routers that we create for each user that is connecting to our central office. This is the activation sequence. So when the user connects to the central office, goes to the captive portal, select the speed he wants to use for connecting to the internet. So we instantiate a new service using the OneFlow API from OpenNebula, which creates a virtual machine, a virtual PDC. And we call the ONOS drivers, the SDN controller, to manage the connectivity of this virtual machine. So ONOS configures the connectivity for the OLT and the clause to route the traffic through the switches. And if everything goes okay, the user gets connected through this virtual router. OneFlow, as I mentioned just now, we're using OneFlow to do some basic orchestration inside the central office. It's the one that, we create like a service template with instructions on what are the steps we need to take for connecting users to the services that the users select. Okay. um, is, as you know, is a REST API, very easy to use. And our view is that we can create a service catalog based on OpenFlow templates or services. And for us, migrating a user from 30 megas to 100 megas or 300 megas is a matter of using the right OpenFlow API and remove one virtual machine and instantiate a new one with the new settings. Now for phase 2, that we started a few weeks ago, we're planning to move to the real infrastructure, okay? So we are getting a real OLT, the 6 switches in the leaf spine configuration, and we are buying a set of servers and a bunch of disks for the storage. We're building this in one real central office located in Madrid, and in the second phase, besides showing how we can provide connectivity services for residential users, we are planning to integrate as well use cases for enterprises. Because our view is that the same infrastructure that is in the central office is able to provide connectivity services for residential customers, but also for enterprises. Okay? And I want to show you how it looks like. So this is the landing page for the Sandstone. We changed the logos. And this is the OpenNebula dashboard that you know. So here in the virtual machines, you can see we have a number of virtual machines. We have the SDN controller, which is the ONOS virtual machine, and the close fabric, okay? If you want to look at how the close looks like, this is the console for the ONOS SDN controller. So I'm going to log in. It's coming. Okay, the resolution is... So this is the view from the SDN controller. Okay, as you see, we have 6 switches, 4 leaf switches and 2 spine switches, and they are connected with links between them. And then we have the OLT that is connected to the leaf 1 here. Okay, so if you see, there are several machines and hosts connected to these switches, and ONOS identifies them once they are moving some traffic here. This is the view from the SDN controller. So the SDN controller is able to define the connectivity for all these hosts and how the traffic from those hosts are being managed in this switching infrastructure. This is the OLT, this is the close. These are the external services. We have the hypercache machine and the DNS. As you can see, all the machines have one IPv4 for management address, and at least one IPv6 management for the traffic, for the service traffic. Okay. If we look at, let me see if we have some virtual PDC. Yeah, here. If we look at one of the virtual CPEs, virtual routers for the customers, you see that the router has several interfaces, network interfaces. Okay, there is one for management as well, but there are several IPv6 connections here. Each of these IPv6 connections belongs to a different VLAN to connect to a different service. The first one is the one connecting the router to the OLT, okay, because the traffic comes from the OLT to the router. And then we have 3 VLANs depending on the service. The VLAN number 1000 is the VLAN to carry out the traffic out of the central office to internet. The VLAN 1001 is the DNS service, and the VLAN 1002 is the hypercache service. So if we go here again and look for the hypercache, yeah, here. You see that the hypercache is also connected to the VLAN number 1002. Okay, so every user that wants to consume a service is a matter of instantiating one interface with a specific VLAN for this service. And we can extend the number of services dynamically for our users. I mentioned the logs and the IDs, which is, well, this is the captive portal machine. If you look at what is the captive portal, this is the landing page for the captive portal. So the first time that users connect to our central office, no matter what he types in the browser, gets to this landing page. And if he wants to get connected, he just click here, introduce the credentials, and then he can choose like this. Then he can choose what the type of connectivity he wants to get in the central office. This is like a bandwidth on demand or dynamic bandwidth internet access for residential customers. So the moment that one user getting now here, we instantiate the virtual router with these specific settings, the 30 megs, 100 megs, or 300 megs. We instantiate the virtual machine for him to be able to consume this service, and then we can start carrying out traffic. Okay. Last thing I want to show you is this. As I mentioned, we are collecting logs, we're fetching logs from all the virtual machines, sending to Elasticsearch repository, and then we create dashboards on top of this. So with this easy setup, we have managed to instrumentalize, I don't know if this word exists, to instrument everything that's going on in the central office. Okay, so we have how resources are consumed in the machines, what are the processes that consume more resources, etc., etc. And this is the very last thing, I promise. Because we are fetching logs for DNS resolutions, we are able to rank what is the URLs that users consume the most. Okay, so in this case is one Ubuntu update URL, because we are doing updates for all the virtual machines. But this way we can classify, okay, in this neighborhood, what is the content that people consumes the most? So what is the service that users consumes the most? And we can inject this information in business intelligence tools or the fourth platform concept that we are creating in Telefonica. And I don't know if we have any time for questions, but let's do. If anybody has some questions, we're glad to answer them.
Any questions? Yep.
Yeah, I'm wondering how does ONOS interact with OpenNebula?
Sorry, hold on.
Rather quick. The way we, that was the simplest integration we ever done over between cloud's operating system and ONOS. Right now, in the implementation that other telcos are doing, the hardest thing is to integrate OpenStack with ONOS, because they had to create, they had to put another piece of software to handle the integration between both of them. Here, what you have is ONOS is a virtual machine running inside OpenNebula, and the integration was seamless. I mean, we didn't spend more than maybe, less than a week to have it working. Actually, we put it to work in a couple of days. There is no problem because OneFlow is capable of doing the service orchestration that using other solutions, you have to do it externally. So we moved all the chaining of the services was done by OneFlow, and that allowed us to to integrate seamlessly. So it was very simple, very simple. We were quite surprised.
Any more questions?
I have a question that's more related to strategy, about the future of this project. How Telefonica could leverage this project to compete with public cloud vendors like Amazon or Azure.
No, esta es la que tenemos interna. Espera.
The idea is not to compete with them, because I mean, just to give you an idea, Microsoft right now and Facebook, they have, each one of them have about 1 million servers, physical servers running. So that scale is not achievable within any period of time. So what we're trying to do is, since we have this capability of having central offices very close to our customers, what we're trying to entice them is to have micro Azures or micro AWS placed in the central offices, and we'll provide them that capability, but not renting square meters, but providing them the infrastructure and the platform to do that. So they are capable, because the problems they're having right now is that, let's say for Microsoft, Telefonica has all our documents, everything is in Office 365. But that creates a problem. When Microsoft started, there was no problem because there were very few users of Office 365. Now there's hundreds of thousands, not even, or even hundreds of millions of users of Office 365. The latency is very detrimental to the end user, because your documents are there. When you want to retrieve them or edit them, it creates a problem. So what we are trying to do is offer Google, Amazon is the capability of running on a platform that we control and bring their content closer to the end user. So I don't think we will ever compete with them.